Hi everyone, I'm Yugen and welcome to the AI language.
That's how dramatic to me it is, shrinking 6 months of work into a week or two. Just a couple of years before the hype really got on with ChatGPT, before that I was hired a large company specifically to develop a text-to-SQL system that would be embedded in their analytics product. It accepts a free text from a user and translates it to SQL and then produces behind a bar chart and all kinds of beautiful visual charts for you just by uttering a few natural words without knowing anything technical about query languages.
What's your take about the whole AI taking our job thing?
So much money is invested in getting rid of programmers because it will save a gazillion dollars to employers because engineers are expensive, as we know. So that's where a lot of the R&D is focused on with your programming co-pilots, with your AI-infused development environments. Yes, to some degree, there will be less engineering positions opening than there would have otherwise been. And yet no one really knows if that's the actual outcome, because when software firms produce so much more, it becomes easier to produce more software, then maybe there'll be more startup just to build more cool stuff at a lesser effort.
Hey everyone, welcome to the AI Language Lab.
Today I have a very special guest. It's Amnon Lotenberg, who is an AI scientist, engineer at Hyro. And he has a lot of experience in everything related to training models, data analysis, and recently prompt engineering and automation with Gen AI, which I'm sure everyone is familiar with by now. So, hi, Amnon. Great to have you here. And for a start, I was thinking you can just introduce yourself quickly, like a few words about your background, your interests.
Yeah, sure. I've been for the last couple of years. I've been employed at Hyro as an AI and an NLP engineer in you could call it core technology team, where I've been building the core components of conversational agents to aid people to get access to their healthcare, usually through big health providers in the United States. A lot of conversational AI. Further back, I've been working in the tech industry for I don't know, over 20 years as a programmer and then a data scientist in many large and small corporations and startups, and been in the past dozen years or so since my thesis. I've been building all kinds of language-oriented applications, such as recommendation systems, classification of what would you next probably like to read or to watch or feel like watching, anomaly detection, and a variety of translation, and a variety of different NLP tasks and data science challenges. And as of late, I've been doing more in the engineering side, enjoying a great opportunity and a great position here at Hyro to really ride on the wave, or you could call it the hype wave, of this latest Gen AI, LLM hype, and getting to use these fantastic new tools and getting to know them very well and to productize. And that's where most of the benefit, most of the value that people are going to see is stemming from.
Yeah, yeah, definitely. And so I would like to hear from you what you think is right now. There is obviously a lot of buzz around this whole topic of LLMs, and my question to you is, what do you think is, how do we separate the buzz from the actual innovation? Like, what is the forefront right now? What are some challenges that you think um, are worthwhile to address?
Wow, challenges is everywhere. And starting, well, of course, it's just limiting us to just the field of producing awesome applications that help people and companies and communities get more value, get more work done. Just there always has been, challenges in the basic scientific research, in engineering and building. First of all, these basic foundational models, these large
Can you
language
give some
models.
examples?
No, I'm just saying that there always was and there still is a great demand for more talent in academia and in the big research labs to research and build these foundational models. Like the Coheres, the Geminis, the GPTs of the world, and a plethora of others. There's a reason why, like every other day, you hear of another bombastic model doing unprecedented feats. Of comprehension and talking and thinking and that we haven't dreamt of before, all in the past 2 years. There's a lot of work done there, and it's a lot of demand for that, and yet that brings a lot of. It's not a product in and of itself. A new like there's going to be a GPT 4.5 I hear next week, or a GPT 5 or 50 few months later. That does not keep me up at night, because we know there always, we got used to the fact that there will always be advances in the capabilities, and it's a matter of time. But that in and of itself is not a product that it is not democratized, so that people that the general people on the street will benefit from, will be able to make a lot of use. Yes, it will help you do your homework better, but it's not, in terms of industry, it's not a big public service or something, a commodity one can wrap in a service and sell to you and give you more benefit, as in be a personal assistant, or provide you with healthcare services, or drive your car, or whatever. It's up to engineers in what you'd call execution companies in the industry, who take these big tools and productize them into something more of value. And there, to point to your previous question, there's a lot of demand and a lot of value to produce. Just for example, a case in point, a few years ago, just a couple of years before, the hype really got on with ChatGPT. Before that, I was hired to a large company specifically to develop a text to SQL system that would be embedded in their bigger analytics product. It accepts a free text from a user and translates it to SQL, and then produces behind the screen, behind a bar charts and all kinds of beautiful visual charts for you, just by uttering a few natural words without knowing anything technical about query languages. And it took us. I was in the data science part, and there was a whole team, on the front end and product and DevOps around that, and it took us, I think, about 6 months to get an first version out there. And today, with the LLMs that we have today, it would take about a week or two, because the inherent capability to translate anything from anything, or specifically a natural language, English, to SQL is already at your fingertips. And all the rest is just wrapping. That's how dramatic to me it is. Shrinking 6 months of work into a week or two, more or less.
Yeah, definitely.
And yet we need, of course, a whole company. You could say it takes a village, or it takes a startup to turn that into a product that actually gives you some value, that actually visualizes, democratizes like the data in your in all those bills in your folder, or all the backend data of some large company or a hospital, to visualize it and produce insights. Okay, you need a lot of business knowledge. You need to know what people need, what they care about, what they don't care about, match that to what these LLMs are good at, not good at, what needs more tailored traditional software engineering to pull off, etc. So, and there will always be a gap. We'll never have this just one all-purpose model or any other silver bullet that will do everything we want for everyone. There will be some tailoring, some adjusting to verticals, to audiences, to markets,
Yeah.
to be of value.
Yeah, definitely. And by the way, I was going to ask you about this text SQL application, because that's something that I find super interesting and valuable. So yeah, I guess we can jump straight in. So yeah, I mean, what you said about the shrinkage of time it takes to develop an app, that's totally something I also encounter. Like 2 weeks, easily you can do stuff that was barely even possible
Yeah.
a few years ago, right? So so what is there any other examples of systems like that you have been working on recently?
Well, recently, like here at Hyro, we make healthcare accessible to patients, specifically around the U.S., by providing an automated agent to speak with you over the phone or chat with you on the chat box on the website, to take care of your healthcare needs, right? Your prescriptions, your appointments, general questions, find where, who, and where, and when, and how you can get your healthcare done. And there are lots of challenges in that. You can't just let a person, even today with the best models out there that we've been trying out, you can't just plug the chat box to an LLM and let them talk, no matter how fancy your prompt looks, or even using multiple agentic systems where one big prompt calls another prompt to do a subtask, and then a third and a fourth, and so on. It won't hold water, because still conversations get, even in this limited domain, conversations are too volatile, too varied. So you need scripts, you need control in order to get more guarantee where the conversation will flow to a certain goal of performing some task. And to your question, like give a more concrete example. So like we like about 2 years ago, we started with the new Chat GPT back then, and other big models that were just nascent then. We thought about this. We experimented with that big LLM idea to plug something to an LLM and try. And like I said, we hit a wall, because it can't handle the variety and volatility of a natural conversation. And then since then, we've been taking a more measured approach, which I see around the industry, is that you take a living, breathing product, probably built with some traditional software engineering, and you start replacing and enhancing and fortifying different components with LLMs. For example, a big challenge when somebody calls into you to a phone call conversation is to understand what are they trying to achieve, what goal do they want. They want to check their credit record, or they want to ask for help. If asking what kind of help do they need, then that's a function. You can send just that particular function into an LLM. This task is very well known in the industry since forever. It's called classification, or classifying an intent. And LLMs are a terrific way to prototype and build a very strong classifier within even a matter of hours if you're in a hurry. Okay, it's
Yeah.
and generating, knowing what to say. You know that you want to offer X to your caller. Okay, then rephrase it in a manner that sounds more conversational, in a manner that, or in a manner that will encourage the caller to respond to you, etc. That doesn't sound mechanic. That has a lot of value. Suppose you're in like a mental health care domain, you want to strike a conversation. You want explainability to your back office side to explain after the fact. Why did we say X to the caller at this point in the conversation? So the LLM in real time or a posteriori in a subsequent revision will explain to you. We said we advised them to call the clinic because only the clinic knows if it is open on Thanksgiving. It doesn't say so on the website. Period. So there are a lot of you need to wrap it up. You want to stay close to the market, stay close to the needs of your users as a strategy, which should surprise no one who's selling anything and providing value. Like, what do users and patients and callers need? What do we need in order to sell, to bring value? We need explainability. We need control so that the conversation does not derail. We need guardrails. We need to comply with industry and legal standards about privacy and ethics, hopefully. We want to be fast if that's an online service. We want to be very accurate, which flies in the face of speed in many situations. You factor all those in. The data, what is the data that this client of mine or customer has? What actions are available at each for the user to take at each situation? You factor all those in, and you come up with a business plan. From there, like an engineer such as myself productizes that.
Yeah.
And the
Yeah.
productization is much faster now.
Yeah. So productization is a key issue here, because to be able to give value to your users, you have to wrap your application inside an interface that they can access and can perform a specific action. And you touched upon very important aspects of Gen AI, what it can do, which is,
Yeah,
in
but
my
could
opinion,
I just,
yeah.
sorry to interject, just to add that you also need to know keep tabs with what Gen AI cannot do. Like one of the first things that I did in my capacity in this position was to rule out and convince everyone that no, we're not going to use an LLM for this particular task. Yes, it's good. You couldn't come up with anything better, but we can just use a very elaborate rule-based system that understands the utterance and translates natural language to this particular task we had dealing with understanding time. Okay, the LLMs are bad with numbers. They're getting better. And we ended up for that particular function of translating an utterance to certain time phrases to use regexes and handwritten rules. We all still do it, all us engineers. We just don't like to talk about it. So it's important to know when to use an LLM and when not to. Because if you can get something done without fancy LLMs or even without machine learning at all, then you should.
Yeah, I mean, of course, if you can solve a problem with the lightest way you can solve a problem is the best, because it's fastest, it's cheapest, easiest. But actually, these are what you mentioned about rule-based and time-based understanding is not necessarily something that LM can't do. It's something that can be achieved more simply, which is therefore preferable than using an LLM when you can avoid it. But there are examples, like what would be some examples where LLMs genuinely can't do a task, and you need to either use a human or not solve it at all.
Yeah. Yeah, we know LLMs still struggle with arithmetic of some numbers that are more complex than 2 plus 2. And you still, even today, don't want to give in one single call to an LLM, give it more than one, two, possibly two and a half different things to think about, because then it digresses.
Yeah.
That's why we have all this hype around agentic systems. Have a big prompt to look at the big picture and call a few smaller, more focused prompts to deal with little aspects of the task you want to compute, or reiterate, call again and again to reiterate on the answer and revise the different ways to try and break down the problem, and such as taking inspiration of how we people sometimes, when you have a big problem, we try to break it down, make, I don't know, a table of pros and cons list, or break a big problem down to a set of small problems, talk about it to our friends. These are all things that we encourage the LLMs to, we make the LLMs do in order to produce more and more accurate insights and conclusions.
Yeah, so using cognitive processes that are useful for humans inside an LLM, it can also be useful for the LLM, like to give them instructions that are cognitive, like what you would ask, like instructions for a cognitive way to break down a task and analyze something. Yeah, because it's the way I see it. I mean, intelligence is intelligence. It's information processing. It works according to certain rules, and these are universal. It's not about whether I have like a silicon-based brain or a carbon-based brain. Either way, the information processing subscribes to the same principles, and yeah, so definitely. Sorry.
I know. I mean, as far as I know, the science is still out. The jury is still out about the science of why LLMs or complex machine learning models, complex neural networks behave the way they do. Why do they converge, or how the hell do they manage to converge on so little or so much data that we train it on? But we find out, scientific community has found out a lot of very interesting insights and things that stem directly, like kind of allude to what you said about how the very basic architecture of how these LLMs are currently built, that for example, the more you let them talk and think aloud, the more accurate they tend to be, which we have these techniques called chain of thought. Say, explain to me the problem and then answer it. Because the more it just so happens, because technically, the more the LLM spews out more tokens, it is a recurrent system. It will read what it just said and then think about it and spew the next token and think about it again. So it gets many iterations of processing and revising the same data, accumulating more tokens that allow it to refine and reach more complex patterns than it would with just one volley of looking at, I don't know, the input sentence and give a yes/no answer. That's how they're built. Otherwise, there must be a lot of other complexities, that in it that make it different from human intelligence or biological intelligence. We don't know yet. We can't map it all out.
Yeah, I mean, of course, it's not exactly the same, but like if you're able to solve certain problems, or to solve certain problems, then you need certain behaviors, cognitive behaviors, right? It doesn't matter, like if you meet an alien that is able to solve differential equations, maybe you don't know anything about that alien, but you know for sure that this alien needs some representation of variables. Otherwise, it's really hard to understand how it would be able to solve the equation, right? So there is the input output tells you a lot about the necessary inner workings of the system which produce this input output, even if you don't fully understand the psychology of the system. Like, of course, we don't really like have a clear understanding of how an LLM works, the same way that we have a clear understanding of our own thinking process. And also, by the way, in both cases, an LLM and a human brain or animal brain, whatever, we don't fully understand or not even close to understand the full process itself. So we know that that LLMs have neurons like we have neurons, but they don't work exactly the same like biological neurons. So there are some similar. The point is that it's complex. Like there is no one sentence answer to this. But then my next question is, does any of this actually matter? Like we have these machines that can basically understand a lot of what we say to them and give accurate answers, increasingly getting better and better. What do we like? Of course, it's fascinating to try to understand how they work, but like, can't we just use them as a black box and achieve what we need? Or do we need to actually start investigating how the internal process?
Oh, well, look, in engineering, like in my position of productizing, no, I don't need to understand a whole lot to do most tasks.
Yeah.
But to build another classifier, another, I don't know, text generator, a rephraser, a translator, um, but to get from, I don't know, 0 to 80% accuracy on any given task we have. But
Mm-hmm.
and sometimes you're building a much more holistic system. Just think of, I don't know, someone building something as general as just a general chatbot. Talk to people who call you about their mental health or about movies. Okay, and direct them, recommend them a movie. Okay, this is a lot more general. And to get from 80 to 90 or 95% accuracy on whatever measurement you have, and I haven't said this, but still, today, as always, most of my work in any task is about getting the data that I want the LLM to see and work on, and to evaluate it, to be able to say, to quantify how good it is. That's really most of my work, and with that framework, you can go very far. Without that framework of robust evaluation, I will be chasing my tail. And still, you'd need to learn, you need the knowledge, more general knowledge about how to squeeze more performance, how to talk to these LLMs, even though it gets simpler on capacities. Improve. Sometimes they diminish from version to version, but mostly in general they're of course improving. You need to know to squeeze performance from 80% to 90 or upwards on split cases when you have just a very complex input or a task. Like I want to, I don't know, I want to renew my subscription and also file a complaint. Okay, now go do these two things without getting confused. And then a third thing, a fourth thing, you need a robust system in code to possibly, it would best to have a system in code to monitor what tasks do we have to do in this conversation. Are we doing them? What is the status of each one? Not let the conversation hang in case an LLM forgets a detail, and build better instructions, guardrails to keep the LLM on track.
Yeah. So this is a lot like error handling in code and building robust systems that are able to stay alive even when they get all sorts of different inputs. So yeah, this requires understanding of how to structure programs and how to structure um, machine learning models properly so they are able to handle these cases, right?
Yes, and the tools to get this done, to wrap, to control, to guardrail, to direct your these models into a product are evolving and spreading and propping up rapidly, at least as fast as the foundational models underneath them.
Yeah. So can you recommend like a specific method or resource for people who want to get started with this?
Started with this, with building.
Learning this, what you just mentioned, learning the guardrails and structuring of the programs around the LLMs.
Look, there are a lot of aspects. I don't know of any. There must be like one already books about this, but one
Or,
guy.
just maybe a keyword
A
to
suite of
refer.
tools. Look, there are numerous tools out there for different aspects of your work. For example, for tools for managing and monitoring, evaluating your call to your LLM inside your system and your product, and evaluating. I said, and our stuff like we've been looking into tools like LangFuse or Langsmith, and to manage and wrap all our calls, give us more visibility and accountability. It does does a lot of tasks for you, which is the first kind of thing you want to think about when you're building a system, and and you want it to last, is to focus on developing your core technology. What is the core technology, the core pieces of code you're going to lay down that no one else can do for you, that will bring value, and buy all the rest, okay, or outsource all the rest,
Yeah.
and all the rest you'll rapidly. We didn't have these tools when we started adopting and implementing these tools 2 years ago. There was nearly nothing out there. We were one of the first on the field to productize something like a RAG or a classifier or a generator. And now we have growing pains because we're going to be outsourcing more and more of our testing and monitoring to these tools. We use online services to monitor language or toxicity, to make sure we are compliant with data standards and privacy standards like SOC 2 or HIPAA. Other tools such as those that for a fallback, an LLM service, an online service will fail you every now and again. It will go offline. We're training and using our own models for specific mission critical tasks. You want a platform for that, for possibly if you're investing in even training. You want training models. You want to use external tools to improve your prompts. It's fun to write first few prompts, and get a kick out of that and a lot of value, but it's not a way to live. You have tools for optimizing a prompt automatically, and save you all this work, which becomes repetitive. And whatever is repetitive and is not part of your core business, then it's harmful for you down the line.
Yeah, yeah, definitely. And I think some of the names you mentioned, I didn't even recognize. So I'm sure I mean, I would look into it, and I'm sure a lot of people can benefit from these pointers. Um, so yeah, and another thing that we briefly touched on, and you just mentioned, is about prompt optimization, which is something that pretty much all of us have to do, even if we're just non-technical users of Gen AI. We're just asking them to write a recommendation letter for us, or an application or whatever. We have to prompt to engineer some sort of a prompt. So I know that like you've described yourself at one point as an AI whisperer. So I was wondering if there is any.
Think about that coin, but
Yeah.
I don't know what it means anymore. Everyone whispers now.
Okay, yeah. I mean, times are changing so fast that even the terminology we describe ourselves as is not gonna doesn't have a very long shelf life. But yeah, are there any techniques or yeah, techniques that you think are valuable for that for prompt optimization for different cases that you encounter.
Yeah, look, when you're getting the hang of it, then yeah, you pick up a small, a short white paper or small guide about good prompting techniques, which is along the line of give the premise. I forgot, there are a few nice acronyms for this. The give Start with a premise. Your person, your persona is this. Give your the task description, the context, possibly a few examples, and then the data, all as much as data as possible, and be specific. And principles which apply to software engineering as well. Keep it as short as possible. Use the minimum amount of words you can to get the job done. Work iteratively, um, meaning you get first version of your prompt and evaluate it, and then do some error analysis. You should first think of course, your evaluation of running it against a test set of realistic examples that you wanted to generate, to solve, to respond to, get a score, see where it goes wrong, tweak something, try again, tweak something, try again, iteratively. That is the most important element of your work. And one of the first things you want to think about mechanizing, because it is repetitive and it is so essential to keep
Yeah.
track. So yeah, that would be the basic structure of the prompt. And you have lots of tools out there, like LangChain was one of the first ones to try to allow you to systematically write a prompt using code, not using free text, to stay structured. Again, there's the premise, the task, context, possibly a few examples, and the actual data at hand, and respond.
Yeah. So the anatomy of a proper prompt, and
Yeah.
yeah, yeah, and I mean, I definitely agree that a lot of times you shouldn't be trying to write your own prompts manually. You should use tools that are
Mhm.
built to structure them in a kind of well-structured way according to the standard form, which is easiest for the LLM to process. Um, and a lot of
You can even
times,
ask the LLM, look, here's a
exactly,
prompt
I
we
was
got,
going to say.
rewrite this.
Exactly, I was going to say because machines are pretty good at communicating with machines.
Hmm. Yeah.
They understand each other pretty well, and humans are much more chaotic and less organized in a way compared to machines. So our prompts can be more messy, less clearly articulated, and I mean the thing that makes us also more interesting is also what makes us more chaotic in a way. Yeah. Um, so I know you. I mean, I'm going to switch a little bit to a little bit of a more technical subject towards the end of our discussion. Um, so I know you worked a lot about graph-based knowledge graphs, embeddings, and machine learning algorithms. So, do you think which of them do you think are still relevant? Do you find yourself you because I can say about myself that I've been doing machine learning algorithms for many years, but recently, since the latest Gen AI models, I find that I'm looking for excuses to apply them, but it's hard. It's getting really hard to find use cases where you actually need to go to the fancy, like cool,
Mhm.
super complicated models.
It's true.
Yeah. So you have a similar experience.
Sad but true.
Yeah.
um, it's still, all these tools are still relevant. What did you mention? Graph.
Graph-based, embeddings, training, or
Yeah.
yeah,
Look,
embedding arithmetic. That's one thing that I have in mind.
look. even today, the graphs are alive and well, encoding your knowledge in the form of a graph where this fact is connected to that fact. This like person lives here, has this hobby which is connected to other people who live here, which is
Yeah,
here,
definitely.
and all. This is a bedrock of a lot of production products. A lot of, for example, that LLMs are involved in is called like have an LLM answer your question based on your data, RAG or retrieval augmented generation. It's infused with a knowledge graph to structure and ground the answers that an LLM will give you using a graph. It's usually under the moniker graph RAG, and for many other applications, graphs are alive and well. But of course, LLMs are doing a lot of the work that graphs and other tools have done.
Yeah,
Embeddings are also an inherent component that one must think about in these applications like RAG, which there's a lot of talent and effort and money invested in improving these and simplifying the systems, but still these like complexities of embeddings of representing your data, your text, your images, your objects, and as vectors, and thus being able to compare what is relevant to what is most relevant to what your user, your customer just said.
yeah,
We still deal with them, talk about them, compare, try and improve them, even fine tune and train embedding models for our critical functions here,
yeah,
as do many others. And yeah, that is part of general machine learning, data science work to get your data, see how it is used, see where your functions lack, and improve your functions on in the service of your use cases and your users. And whenever you need something more mission specific or a lean and mean, quick model and lightweight and a greener, less polluting model to run in production, then you go
yeah,
and grab a small model, a small text processing model, and
yeah,
fine tune it on your data, which also the tools for that have become quicker and simpler and democratized.
yeah,
Using a lot of tools from Hugging Face to fine tune our models as of late, and I was comparing it. Like you said, it's harder to justify. It's so much
getting
quicker
harder.
to
Yeah,
prototype something with an LLM from the shelf and a decent prompt. You're right.
yeah, yeah.
We still don't
And
know
you
where
know,
it's going to converge. I'm sorry.
no, go ahead.
No, we don't know where this is going to converge, where a new balance, a new world order of how to build an intelligent application will look like.
Yeah, yeah, and I mean, I would ask you, maybe some people are, viewers are expecting me to ask you any questions about the future. I'm not going to do that because I think anyone who says anything about the future at this point is just, it's a fun game, but I wouldn't
Yes.
take it any seriously. Um, we have the present. That's all we have. The future is, whatever's going to happen. Um, and that's why I really appreciate the pointers and the references you gave. I think that's where it's at right now. Like anyone who wants to learn about AI or get better, um, getting into this, then looking at some of these tools and some of these keywords is the way to go.
Look, yeah, as a beginner, as a novice, first, go to, for example, learn a couple of courses, quick courses, and like from Coursera, if from nowhere else, about, first steps in coding in
Yeah,
Python and AI tools, prompting or agentic systems or whatever,
yeah,
and be playful. Go run them, get your hands dirty, and focus on your goal, your mission statement, what you're trying to create, and what service and value you try to create, and then you'll see how these new tools meet your needs.
yeah, yeah, definitely. that's how a lot of us started. I took some Coursera classes, I mean, back in the prehistoric times, but uh, I haven't checked out their prompting classes, but I'm sure they have some
Very
useful
good.
stuff. Yeah, yeah. Um,
There are
and
learning.ai,
mhm.
somewhat of an offshoot, I think. Yeah, very good courses. Even a lot of them are for free and very, very practical.
Yeah. Um, so, as a concluding question or discussion topic, I'm going to bring up something a little bit controversial, which is what's your take about the whole AI taking our jobs thing?
Um, Look, you want to look at the economics and the politics of it, I think, to be practical. And the so much money is invested in getting rid of programmers because it will save gazillion dollars to employers because
Yeah,
engineers are expensive, uh, as we know, and so that's where a lot of the R&D is focused on with your programming co-pilots, with your AI infused development environments like Cursor, which is an IDE that is gaining a lot of traction now. We're even testing it out here. Um, and the like, which means that yes, to some degree, there will be less engineering positions opening than there would have otherwise been, and yet no one really knows if that's the actual outcome in fulfillment of time, because then if when software firms produce so much more, it becomes easier to produce more software, then maybe there'll be more startups or more projects and departments opening just to build more cool stuff at a lesser effort. um, it's hard to tell, but of course where the money is coming from. So
yeah,
yes, so at the very least, you better know how to use these tools better than the average Joe.
yeah, yeah, definitely.
Yeah, so
Um,
go play around. Even if you know nothing, if you're uncomfortable with changing your software development environment, and you feel comfortable just typing all your code in by yourself, you should play around. You should go see what the kids are playing with and get to
that's
know them.
always a good idea.
Yeah.
Yeah. So basically, you're saying there are the skills that are needed in the market, there will always be skills needed in the market. I mean, that's a bit my words, but I'm guessing that's what you meant. But it's evolving. What is a useful skill? So it used to be you needed to be an engineer. Now you need a little bit of a different skill set to be useful.
Now it's not so important to be a code monkey or a code wizard, to know how to fashion your idea in 2, 3 concise lines of code. Now
Yeah,
you need to know code to understand and tell the difference between, or be able to test externally if this code is good or not. But for example, this is the easiest task. That a GitHub Copilot or a Cohere model or excel at there are other models to just write your snippets of code for you, write entire systems, blow up an entire code for an entire web service for you. Back
yeah,
end, front end, and I don't know what CSSs and HTMLs and the works. All this is becoming automated fast, and
yeah,
slowly, surely, other aspects. So, engineer should, of course, know the basics, but more and doesn't need to be a code wizard as before, and that's how. I read some survey that something like 40% of all code, this is like a year ago or half a year ago, 40% of all code is generated by GitHub Copilot. Then again,
oh,
this
I
was
would
written this was commissioned by Microsoft itself, so I'm not sure, but it's alarming. Okay.
Yeah, yeah. I mean, I think it makes sense because machines are writing code so much faster than us. It's not even a competition. You know, we are not the ones who should be writing every single line. We are the ones who are giving instructions, feedback, and revisions, right? So that's by itself. I mean, yeah, that doesn't alarm me so much. But yeah, so then the focus is shifting from being a code monkey, like you said, to being something a little bit different, which is more about
To manage a
understanding.
code monkey.
Yeah, like someone who can manage Code Monkey or a team of Code Monkeys and have an understanding of the architecture as a whole, as opposed to the lowest level. Right. Um, all right. So we are approaching the end of our discussion. Any final remarks, ideas, suggestions, questions? You know?
Well, thanks for the great opportunity to talk with you
Oh
here.
yeah, most welcome.
Yeah, thanks. And to anyone out there, yeah, first, have fun with your code. Feel
Yeah.
privileged to be able to see all this revolution and play with it with your own hands. And like I alluded to before, so be true to what you really believe in, the change you want to do in the world, even if it's just your day job, and be aware. These tools are they can have a lot of unintended effects. They could derail and say things, and of course they're very they pollute a lot. So use them responsibly as you would by I don't know, flying a plane, a commercial airplane all around the world for
Hmm.
your living.
Yeah. That's a very good point. Something I think we should all take into account. All right. It's been a pleasure. Thank you so much for being here. And I'm definitely looking forward to our next discussion.
Me too. Thanks,
Yeah.
Yugen.